Now you can put your roll numbers in the chat box. Okay. Good afternoon, all. I welcome you all for today's session. In this today's session, we are going to discuss the design of compression mold and transfer mold. Okay. Now, in this today's 1 hour session, we will discuss the first. We will go through our necessary points. That is, what is the central idea of the chapter, importance of the chapter, and what will be the outcome of this chapter. And after that, we will discuss the design and main parts of the compression mold. Okay. For performing this compression molding of the plastic parts, we are using the compression mold. And what are the general parts in that compression mold, and what is the function of each part, that we will discuss in today's session. Now, first, we will go through the what are the syllabus content for this chapter, and after that, we will start the design and main parts of the compression mold. Okay. Now, these are the contents for this chapter. This is the chapter number fifth. Okay, fifth chapter, chapter number 5 from our syllabus, and name of the chapter is design of a compression mold and design of transfer mold. Okay. Now here, in this, we are going to discuss the design of compression mold only, and related to the transfer molding process, we are going to discuss its types, and how to the automation is performed in the transfer molding. Okay. In this first content, part A will be design and main parts of the compression mold, then standard insert mold body, then design of loading chamber, design of punch, ejectors, stripper pins, guided pins. All this part we are going to discuss. In this design of the compression mold, one numerical will be there, that we will discuss, and that same numerical we are going to repeat it again in our practical hours. When our third or fourth practical is based on this design of compression mold only. And in the second part, that is part B of this chapter, will consist of transfer mold, then its types, then what will be the main parts in the transfer mold, and their functions. And after that, we will discuss how the automation can be done in the transfer molding process. Okay. This will be the, and these are syllabus contents I have highlighted point wise. And now, what are the prerequisites for this chapter? For this chapter, you should have the basic knowledge related to the plastic materials, related to their classification, their properties. Then you should have the basic design knowledge. After that, your basic design knowledge, and you should have the specific knowledge related to the how the compression molding and transfer molding is performed. Already this part we have seen, this introduction to the plastic material we have seen in the chapter number first chapter, and this compression molding and transfer molding process, already this we have discussed in our second chapter, processing of the plastic materials. Then I will just take a review of the compression molding process here, and after that we will discuss the main parts of the compression mold. Okay. Before that, we will discuss what is the meaning of this title of this chapter is design of compression mold and design of the transfer mold. Okay. Now, as far as this design word is concerned, whichever ideas or concepts are there, that you have to convert into the drawing. Whichever ideas or concepts are there in your mind, that you have to convert into the drawing, that will be termed as a design. Now, as far as the design of the plastic parts is concerned, whenever when you want to design the thick plastic parts, okay, thin plastic parts, you can go for injection molding, extrusion molding, number of processes are there, or you can go for blow molding also. But whenever you want to design or manufacture the thick plastic parts, then you have to go for compression molding or transfer molding. Whenever you want to design the thick plastic parts, and basically for thermoset materials, you have to use compression molding or transfer molding. Okay. For manufacturing the thick plastic parts using thermosetting materials, or for processing the thermoset materials, basically we are using this compression molding and transfer molding process. And to perform this molding process, a specific mold is required. And in this chapter, we are going to discuss the how or how this mold is designed for compression molding process, what will be its basic parts, what is their function, and how these are practically used. Uh, that we are going to discuss in brief. In this, we are going to discuss the basic elements and the basic procedure for design of the compression mold. And as far as the transfer molding process is concerned here, just we are going to discuss in short, and we are going to discuss in brief related to its types of the transfer molding process in this chapter. Now, what is the center? Already I have told you that the design of compression mold for different plastic parts, and the transfer molding process with its types, and how the automation is used in the transfer molding process, that we are going to cover in this chapter. On the importance, what is the importance of this compression molding and transfer molding? Already I have explained it. That is the to manufacture the thick plastic parts by using thermosetting material, that is not possible with the help of extrusion molding or injection molding. So for that we are going for this compression molding and transfer molding process. Depending on the thickness of the part, you can use compression molding or you can go for transfer molding process. So at the end of this chapter, what will be our outcome? At the end of this chapter, we will be able to explain the types and main parts of the compression molds and transfer molds, and we will be able to design, specifically design, we will be able to design the compression mold for a given thermoset plastic part. Okay. That design procedure will be included here, that will we will discuss through one problem statement and its solution. Okay. Now, we will first, I will take the review of this compression molding process. Okay. Already this we have covered and will not explain it in brief. Already you can refer my that recorded lecture is there for this compression molding process. Next, I will take a short review. Okay. In this compression molding process, this compression molding process is a forming process which we are using to give different kinds of the shapes for the plastic parts. Okay, and generally this process is used for thermosetting materials. Okay, we can use it for thermoplastics also, but it is preferred for thermoset plastic materials. Okay. Then generally this compression molding process consists of two stage. The first stage is the preheating stage and second stage is the pressing stage. Okay, so for better understanding of this, I will show you this is the diagram. It consists of, this is the upper half of the mold and this is the lower half of the mold. Upper half is the movable half of this mold. It consists of this, you can say that the punch or press, and this is the lower half of the mold which is fixed. Okay, this is the lower half of the mold. This is the ejector pin, and this is the charge or the raw material or your plastic material. This is a preheated charge or raw material is taken in this lower half of the mold, and in the second stage pressure is applied with this press or punch. Okay, and this is now in this stage you have to keep it for a certain period of time so that the pressure is applied, and it occupies the desired shape and size, and after that it is ejected with the help of this ejector pin. This is the compression molding process, and this compression molding process is generally used for thermostatic plastic material. Now, for example, you can manufacture the different products like dinnerware sets, then radio cases, then automobile exterior panels, whichever automotive vehicles are there. Then different home appliances can be manufactured with the help of this compression molding process, and material will be used the thermoset plastic material we are going to use, like polyurethane. Then you can go for urea formaldehyde, phenol formaldehyde, and different types of phenolics, silicones, and unsaturated polyesters. All these materials can be thermoset plastic materials can be used. You can manufacture the different components. Okay, and this compression molding process is high volume and high pressure method. Okay, and these are the parameters of which are very important as far as this compression molding process is concerned. Quantity of the charge. Okay, quantity of the charge is nothing but your material, plastic material. Then pressure of the molding process, it should be in this range only. And molding temperature of the mold, it should be in this range, 150 to 200, you can say that. And the cure time. Okay, cure time or curing time is nothing but the time required to harden the thermosetting material to partially complete it or totally complete the polymerization process. That will be termed as cure time or curing time, and generally for this compression molding process, it is in the range 1 to 5 minutes. Okay, this is the basic diagram for this compression molding process. Okay, this will be the charge. This is the diagram. Compression molding process. This is the first stage. Charge in this cavity. Okay, this is the lower half and upper half. Upper half of the mold, it consists of punch, and lower half of the mold cavity will be provided. Mm, In preheated charge or material is taken in this cavity and in the first stage. In the second stage, pressure is applied. Okay, here that is the pressing. Then curing will occur here, and at the end, here pressing and curing will occur. And at the fourth stage, after providing the sufficient curing time, in the fourth stage, the molded part is ejected with the help of ejector pin. This is the compression molding process. Generally, it consists of two stages only. This is the preheating and pressing. But if you elaborate or try to differentiate these stages in brief, then you can say that it is the preheating or filling of the charge, then pressing and curing in the second and third stage, and ejecting the part from the cavity with the help of ejector pin. Fourth stages may be there. Okay. Now these are the advantages of this compression molding process. Internal stresses are very less, and warpage will be very less. And here in this process, as gates, runners, and screw arrangement is not required. Okay, means whichever extra tooling is required, it will reduce the cost of the tooling. Okay, then it is good for small production runs, and you can manufacture the large sized products also. These are advantages. Disadvantages: wastage of material is more. Then labor cost, because skilled workers are required, high labor cost is there. Then sometimes processing time or curing time may be high. Okay, so it becomes time consuming process. And as we are manufactured, complex shape components cannot be manufactured by this process. Then sometimes defects can occur, like flash, uneven parting lines. These kinds of defect may present in the final product. Then here, as here we are using the punch, we are applying the pressure with the help of that punch. Then there may be some wear and tear due to the repetitive pressing. Okay, there may be wear and tear, and whichever scratch is formed here, it cannot be recycled. These are the disadvantages. Some the applications, these are dinnerware sets like these plates, then the plastic buttons, then trays, is hairbrush, mirror bodies, then electrical wall receptacles, then your energy meter casing, this top casing, all these are manufactured with the help of compression molding process. So dinnerware set, plastic dies. Okay. So this is the overview of this process, compression molding process, its principle, parameters, and procedure, advantages, disadvantages, and applications. And after this, the next part is design of this compression mold. Now, as far as this compression mold is concerned. Okay, this is the diagram. These are the different parts, okay, which I have highlighted in that slide. Okay, this is the top plate. This is the top plate. Its names are not clearly visible. Please try to see this cursor position. I will explain the names. This is the top plate. Okay, this is the top plate, and this is the spacer block. Okay, this is the spacer block here, and here also one spacer block is there. Okay, spacer block. Two spacer blocks are present. One at this point. This is the spacer block. This is also spacer block. Then this is the punch plate, and this is the punch black plate. Okay, black, not black, it is back plate. Punch back plate. This is the spacer block. Top plate, spacer block. This is the punch black plate, and this is the punch plate, and this is the punch or punch insert. Okay, this portion is punch or punch insert. Similarly, this is the cavity or cavity insert. This is the cavity plate, and this is cavity back plate. And whichever circular holes are present here, these are, you can say that these holes are provided, or you can say that this is the heating system. Then here these are ejector pins. This is ejector plate, and this is ejector back plate, and this is the bottom plate. Okay, this is the bottom plate. So these are the different parts. This is the compression mold and its different parts. Okay, I will repeat it again. This is the top plate. This is the spacer block. Then this is punch or punch insert. Then this is the punch plate and punch black plate. Okay, back plate, you can say that. And this is the cavity plate, and this is cavity insert and cavity back plate. This is the spacer block. These are ejector planes, ejector plate, and ejector back plate. And this is the bottom plate. So this is related to the names. This is the name of the parts or constructional details of the compression mold. These are constructional details. One more diagram I have collected. Okay, this is the general diagram, general constructional details of the compression mold. And these are different parts will be there. Now I will show you another diagram. Okay, this is one diagram. Here also main parts are highlighted. All parts are not highlighted here, that's why I have collected. Okay, this is the um, diagram which consists of all the parts. Here almost 16 parts are there. Okay, 16 parts are there, and according to the number mentioned, okay, according to number mentioned in each slide. Okay, this is the first part I have highlighted here. This is the first part, top clamp plate or top plate, you can say that. Okay, this is the first part. This is the top clamp plate. Now, what is the function of this top clamp plate? This first part is the top clamp plate. This is the top clamp plate, or you can say that the top plate. Now, what is the function of this top plate? It will now this top plate will help you. It is connected to the one hydraulic arrangement. With help of that, you can apply the pressure during the compression stage or pressing stage. Okay, this is connected to the an hydraulic arrangement. With help of that, we are going to apply the pressure. This is termed as the top clamp plate. This is the first part. Now the second part in this list. Okay, please read the name. Thermal baffle or thermal insulation board. Okay, this is the second part. Okay, here please see the cursor carefully, numbers. This is the second part. This is the thermal baffle or thermal insulation board. Okay, Now this is thermal insulation board or thermal baffle. What is the function of this thermal insulation board or this thermal baffle part number two? It protects, okay, it means it avoids the loss of heat and saves the energy. Okay, avoid the loss of heat and saves the energy, and also it protects whichever that hydraulic press or hydraulic mechanism is there, which protects its parts from the heat. Okay, whichever heat will be there in this mold cavity, that heat it avoids the transfer of this heat from this region towards the hydraulic arrangement. Okay, so that its components does not get damaged due to the heat, and also it prevents the loss of heat, means it prevents the it saves the energy, and this is the function of this thermal baffle or thermal insulation board. This is the part number two here. Okay, now please refer after the second part. We'll see the part number three and four. Okay, now this is the part number three. Please see here part number three and part number four. Okay, cavity plate and core plate. Okay, please see these parts and try to understand in whether where that part present in the diagram, and try to understand their function. Cavity plate and the core plate. Okay, this is the cavity plate. This part number three, and this is the core plate. Now this cavity plate, as you can see that uh, I have added this point here. You can read it. This cavity plate, it allows you to fill the plastic material. Wait, here it will get clear. This is the cavity plate. Now, what is the function of the cavity plate? Now, in this cavity plate, it will provide you with the shape. Desired shape will be given here with the help of this cavity plate, or it will provide the support to give the cavity. Okay, cavity or cavity insert. Depending on this, you can give the different shapes, and the whichever plastic material is there, it will flow in this. Okay, it will flow in this cavity plate. Now the next is the core plate. This is the core plate. This is the core plate. Okay, now due to this core plate, it will help you in the opening and closing of that mold. This, what is the function of this core plate? It will help you to the opening, to open the mold during when you want to over that material, or after part is manufactured, to open it, and to manufacture that particular part, to close the mold. It will, that core plate will help you in the opening and closing operation of that mold. It is the function of this core plate, and this is the cavity plate. Okay, this cavity plate will create the cavity of the desired shape and size, and that material will enter, and it will allow the entrance of the material, okay, into the cavity. Then next fifth part we will take. Okay, is I will take two parts at a time. Okay, this is the fifth part, stop block and guide pin, guide pillar or leader pin. The fifth part, this is the fifth part. This is the stop block. Okay, stopper block. Again, it is named as the arresting block or arresting stop. Okay, this is the stop block. The function of the stop block, it will stop the mold from closing. Okay, when sufficient material is not entered into the mold, and suppose that the mold is trying to close, it will avoid that closing. Then this is the guide pin. Okay, it will align, it will help. This is the guide pin, guide pin, guide pin, this one. It will help you to align this core plate and cavity plate. Okay, this is the cavity plate and this is the core plate, and it will help you to align this or guide this cavity plate during the closing of that mold. Okay, then the next seventh and eighth. Okay, function of this guide pin, provide vertical guide to the cavity and core before mold is closing. Okay, means it ensures the proper alignment of the cavity plate and core plate during the closing. Then the vertical guiding plate is there. Now during the closing only, it will provide the guidance. This is the vertical guide pin or guiding pin here, or guiding plate, you can say that. Vertical guiding plate. Okay. Here it is also helpful for providing the proper alignment, okay, of this core plate and cavity plate for proper closing. Provide the alignment for proper closing of the cavity plate and core plate. A core cooling system is there. It will provide the auxiliary support. This part number 8. Now please see this part number 9, 10. I will first go through the names. This is the ninth spacer block. Then 10th part is the ejector pin, ejector plate. Okay, spacer block is there. Ninth is this spacer block. This is the spacer block. Then these are the ejector pins. Then 11th and 12th, right? Again, then this is this spacer block. These top plates, these are the spacer blocks. Now, why these spacer blocks are provided? Now, these spacer blocks are provided there to provide the space for this ejection system. Okay, to increase the space for this ejection system, the spacer blocks are provided. And the 10th part, this one, these are the ejector pins. These are ejector pins. These ejector pins are helpful for ejecting the component after the sufficient curing. The manufactured part or final molded part is ejected from the that mold cavity with the help of this ejector pins only for the easy removal of the molded part from the mold cavity. Okay, then these are 11th and 12th. Okay, part number 11 and 12, ejector plate and ejector pin cover plate. Okay, this is the whichever this part number 12 is there. These ejector pins, for these ejector pins, it will provide this support or space for fixing them. This is ejector pin cover plate. Okay, part number 12, and this is the ejector plate. Okay, on this ejector plate, These ejector pins along with its cover plates, ejector pin cover plates are fixed. Okay, or provide it will provide the act as a base for ejector pin cover plate and ejector pins. Okay, this is the spacer block. It will help you to increase the space of this ejection system. Okay, this is the spacer block, this top and bottom. It's then this is the these are ejector pins for proper removal of the molded part from the cavity. Then this part is ejector pin cover plate, and it is part number 12. It will provide the space for fixing this ejector pins, and this is the ejector plate. Overall support for this ejector pins and ejector pin cover plate is provided by this ejector plate. Okay, then four parts are remaining. 13, a heating system, return pins, then bottom plate or bottom clamp plate and screws. Okay, this point 13 point, these are the heating system. This is the arrangement provided here with the help of these arrangement. This is the 13. You can see here, through this is the heating system. Through these holes we are going to provide the heat. Okay, by with the help of different heating arrangement. Okay, like electrical cartridge you can use to provide the heat to that mold cavity. This through these holes we are going to provide the heating system or required heat. Okay, then this is the back plate. Okay, bottom plate you can say that, or bottom back plate, or simply bottom plate. This is the bottom plate, as this is the top plate, top clamp plate. This is the bottom clamp plate. Okay, this bottom clamp plate function is same as that of the top clamp plate. uh, as this top clamp plate help you, or it will help you to connect the hydraulic arrangement to apply the pressure during the compression. This will also help in that only. Okay, this is the bottom clamp plate or simply bottom plate. And after this, these are the screws. Okay, for fitting this, for fitting the different, whichever a hydraulic arrangement is there, for arranging or fitting it, and these screws are required. These are part number 16. One more part I have left, one part is missing. Sorry, part number 14 I think. Okay, return pin or pushback pin. Okay, this is the return pin 14. This is the return pin or pushback pin. Now this return pin will help you after removal of the part with the help of the ejector pins. It will help you to bring the ejector pins in the initial stage or home position. These are the return pins or pushback pins. Okay, these are return pins or pushback pins. It will help the ejector pins to come to its initial position or home position. After ejecting the part, their position will be changed, and to come back to the initial stage, these return pins or pushback pins are used. Okay, so these are the parts, almost 15 16 parts are there, and each part will play very important role in this compression mold. Okay, we have discussed the all the parts here. Almost 16 parts are there in the compression mold. I will summarize it now. Sorry, top clamp plate, then thermal buffle, then cavity plate, cover plate, then stop block, guide pin or guide pillar, then vertical guide plate, core pulling system, then spacer block, ejector pin, ejector plate, and ejector pin cover plate, heating system, a return pin, pushback pin, then bottom plate or bottom clamp plate, and screws. These are 16 parts we have discussed. These are the main parts in the compression mold which we are going to use for doing the compression molding of the plastic parts. And along with their names and their position, we have discussed their function also. What is their specific function in this compression molding process? Okay, this is the first part. I will take just revise it. This is top plate or top clamp plate, and here this is the bottom plate. Okay, for your easy understanding, this is the top plate and this is the bottom plate, or also you can say that this is the top clamp plate and this is the bottom clamp plate. Okay, what is the function of this top plate and what is the function of this bottom plate? It will help you to connect the hydraulic arrangement. With the help of that hydraulic arrangement, we are going to apply or get the necessary pressure in the compression molding process. That is the function of this top plate, and this is the bottom plate. And then this is the thermal buffer. Okay, thermal buffer or thermal insulation board. Okay, it will protect this. What is the protection? Which parts require the protection? Whichever hydraulic arrangement is there and its parts, it protects them from the high temperature, and also it avoids the loss of heat or saves the energy. Then this is the cavity plate and this is the core plate. Now this is the cavity plate. Now this cavity plate will provide you the gap, or it will help you to give the required shape and size to the your plastic product, and it will help to, or it will give the place or entrance to the your plastic material. Your plastic material is there. Then this is the core plate. This is the core plate. It will help you in the opening and closing of the mold as per your need. And this is the spacer block. Okay, it will try to stop whenever before, sometimes before filling the necessary quantity of the material or your charge, sometimes the cavity may try to close without taking the sufficient quantity of the raw material. It will stop it. This is the support block. Okay, then these are the guiding pins. These are vertical guiding pillars, and these are vertical guiding pillars, and this is the guide pins. Okay, now and this will align the cavity plate and core plate during the closing. Okay, the function of this vertical guide plate and this guide pins is same. This will align the cavity plate and core plate during the closing of the mold. Okay, this is the core pulling system. It, and then these are the spacer blocks. This is this one and this one. This is the spacer block. It will help you to increase the height of that ejection system, and according to that you can adjust the ejection system as per your need. Then these are the ejector pins. It will help you to remove the molded part from that cavity. The ejector pins. This is the ejector plate, and these are the ejector pin cover plate. Okay, this is the cover plate. Cover plate will act as a base for that ejector pins, and this ejector plate. This is the ejector plate. This last one is the ejector plate, and this is the ejector pin cover plate. On that ejector pin cover plate only these ejector pins are fixed, and this ejector plate will act as a support element for the ejector pin cover plate and ejector pins. Then each part is remain. This is the holes. for providing the heating system. Okay, 13, part number 13, holes for providing the heating system. You can use different heating systems like electrical cartridge. Through the electrical cartridge, you can provide the heating, okay, with the help of these holes only. You can, or you can go for oil medium or steam, and through that these holes you have to provide that medium to provide the heat required. Okay, then these are the parts. Okay, given one part I forgotten. I think this one return pin is there. The return pin, what is the function of this return pin or pushback pin? It will help you to bring the ejector pins. After that ejector pins are ejecting the molded part from the mold cavity, their position gets changed, and to bring them back to their initial position or home position, these return pins or pushback pins are used. So these are the different parts which are present in the compression mold, and their function. Okay, so in this way, in this today's session, we have discussed the compression molding process. I will now summarize the session. Those who have joined late, please put your attendance in the chat box. And in next session, we will take the numerical. Okay, we will discuss the numerical and design of the loading chamber, then design of the punch. And based on that I will explain with the help of numerical only. Okay, in this today's session, I will summarize the today's session. We have started today's session. Uh, in this session, we have learned the main compression molding process and main parts of the compression mold. Okay, we have started this chapter with its contents, then prerequisite, then title of the chapter, central idea of this chapter, importance of the chapter, and what is the expected outcome of this chapter. And then we have discussed the compression molding process and its parameters affecting this compression molding process, and steps involved in the actual compression molding process, and advantages, disadvantages, and applications of compression molding process. Then we have discussed what are the main parts in present, general main parts present in the compression mold, which we are using in the compression molding process. So these are the main parts. This is the diagram. This diagram is not, this is the top plate, spacer block. Okay, this is the punch, punch insert, and this is the punch plate, punch back plate. Okay, this is the punch plate will hold, it will hold or it will support the punch, and this back plate, punch back plate, will act as the support for this punch plate and punch insert. Okay, so similarly, and this cavity insert, cavity plate, cavity back plate is there, and spacer block, ejector pin, ejector plate, and ejector back plate and bottom plate. Okay, or you can refer this diagram also. This is the diagram and numbering is provided here, and according to these numbers we have discussed the parts and functions. Okay, this is part number one, top clamp plate. Then this is the thermal buffer. Okay, thermal insulation board, you can say that. Then cavity plate. Then part number four, core plate. And this is the stop. Okay, you can say that stopper. And then this is the guide pin, vertical guide pin. And this is the core pulling system. Okay, spacer block. This is stopper block, and this is the spacer block. Don't get confused. This is stopper block. This is the spacer block. Then these are ejector pins, ejector pin cover plate. Then this is the ejector plate. And this is the holes for heating system. These are pushback pins. You can say that reverse pins or pushback pins. And this is the bottom plate or bottom clamp plate. Okay, reverse pins or pushback pins. All these are the parts along with their functions we have discussed then. Okay, so in this way, in this today's session, we have discussed the compression molding process, its basic principle and steps involved, advantages, disadvantages, application, and along with that, main part we have covered is how this compression mold is there, means what are the constructional details of the compression mold used in this compression molding process of the plastic parts, the constructional details and the function of each part we are covered here. In the next session, okay, in the next session, we will take the numerical. Okay, if you are having any queries, you can put that in the chat box, otherwise I will stop the session here only. Thank you for attending this session. Thank you.